Okay, so we have $12,000 to invest. What is going to give us a greater amount? We have a higher interest rate compounding monthly, 6%, or a lower interest rate compounding continuously. So we want to take our formulas. So our first formula is going to be for periodic interest. Okay, 1 plus r over n to the nt. And then the second formula for continuously compounding interest. So P times e to the rt. So in our first one, we've got a P of 12,000. Okay, then our interest rate is 6% compounded monthly. So we're going to go 1 plus 6% as a decimal is 0.06. Monthly is 12 months a year. And we didn't get a years here. Nobody pointed that out. So, well, it depends on our time, actually. So let's just do 5 years. Okay, let's do 5 years for our time. Okay, and let's go ahead and work that out. So we're going to go in our calculator. .06 divided by 12. We're going to add that to 1. And then we're going to raise it to the 12 times 5, so to the 60th. And then we're going to multiply by $12,000. So $16,186.20. Okay, now let's look at our other formula. For continuous compounding interest, we'll go $12,000 and then e to the 0.0574, and then we're doing 5 years again, so times 5. We can put that in just like that. So 12,000 second e 0.0574 times 5. And that gives us $15,989.09. Is that 5 cents? 9 cents. Okay, so after 5 years, this is going to yield the most. But let's check this out with 20 years. So let's say I just change this and I make that 20 years. And I change this to a 20 as well. Let's look at what happens in this case here. So 0.06 divided by 12 plus 1. Then we're going to raise that to the 12 times 20. And then multiply by $12,000. So first time $39,722.45. Okay, and then let's take a look here if we do the second formula. So 12,000 second e to the 0.0574 times 20. $37,822.59. So 37,822. Okay, so this is still going to be the greater amount after time. So if you're not given a value in years to do, then you want to test some values. So test 2 values of years, in a reasonable time frame. Don't do like 100 years because you're probably not going to live that long. Some of you might, but you're probably not going to have your money in the bank for that long. So do like 20 years, 40 years, things like that. And then if it works on both, then that's going to be the greater amount. All right, another part of this chapter is being able to take some real world scenarios, given equations, and find the values. So let's look at this. The formula S equals C, 1 plus R to the T, is going to model inflation, okay, where C is the value today, R is the annual inflation rate, and S is the inflated value T years from now. So if the inflation rate in the housing market is 5.5%. How much will a $250,000 house be worth in 9 years? Okay, so we're going to plug that in. So C is going to be the value today. So we have S equals 250,000. And then 1 plus our rate. So 5.5% interest rate as a decimal is 0.055. And then to the 9th power. So in my calculator, that's going to be 1 plus 0.055 to the 9th. And then we're going to multiply that by 250,000. So $404,773, to the nearest dollar, so 404,774. Okay, so in 9 years, if we keep up this inflation rate, that's how much the house should be. If we look at the past 9 years of data that has followed it, now economic times are certainly very uncertain at the current moment, so this may not ring true. It might be a smaller inflation rate, but you never know. You never know what could happen. But generally, housing prices do tend to go on the upward trend. All right, let's look at these logarithms here. So we've got, I'm just going to add an equal since we're trying to evaluate this. Oh, my pen is not cooperating at the moment. There we go. Okay. So I'm just going to add an equals x here so I can find out what x. So remember log bay, this is my base, my answer, and my exponent here. So my base is 3. My answer is 1/9. My exponent is x. So I know 3 squared is a positive 9, but what would make it go under a fraction? Need it to go under a fraction. Any takers? You guys are very quiet today. Okay, so what would make that go under the 1 is a negative value. So if I took this and went 3 to the negative 2, that's going to become 1/3 squared, which gives us that 1/9. So our answer, -2. Okay, this is our rule here. Remember log B1, that equals 0. Okay, remember because if my base is 5, my answer is 1. My exponent is x. Anything to the 0 power is 1. Okay, then let's see. So this is another rule here where log base 4, the log base 4 and 4 cancel out. This equals 8. Okay, and here this is my base. This is my answer. This is my exponent. So my base is 4. My answer is x minus 5, and my exponent is 2. So this is just an equation. 4 squared equals x minus 5. 16 equals x minus 5. And then I'm going to add the 5 to both sides, and I'm going to get 21 equals x. Okay, then this last problem here, you've got your log. Here's your base. Here's your answer, and we can get an exponent there. All right, so our base is 4. Here's our exponent. Okay, to the x equals log base 3, 81. All right, well, let me see if I can take this and find what this is. Okay, so if I just take this and I convert this over to an exponent, this is, my base is 3, so hold on, write it over here. Okay, what does that equal? Well, my base would be 3. Okay, my answer would be 81, and then my little question mark goes here. 3 to what power is 81? I'm pretty sure that is 3 to the 4th. 3 to the 4th power is 81. Okay, so if 3 to the 4th power is 81, then log base 3, 81 equals 4. So then I can take that 4, replace it right here. So 4 to the x, here we go. 4 to the x equals, now this is 4. Well, then that would just be 1. So the answer for that one would be 1. All right, so those are the practice problems.